Hi, Poema. I have your quiz here, so let's go over the questions that you missed. The first one says, look at the graph. To find the rate of change, Kevin did the following. What was Kevin's mistake? So let's just look at what we would do. When we calculate slope or rate of change, we're going to take the two ordered pairs that we know that the line goes through. So this first one down here is 4, 0, and the one up here is 0, 2. So the first thing we have to make sure we're doing is naming the points correctly. And I think I have to erase what I just wrote so that I can scroll down. So let me get, there we go, now I can see it all. So let's label those again. This one was 4, 0, and this one is 0, 2. So he did 4 minus 0 and 0 minus 2. Well, so the mistake is he put the x's on the top and the y's on the bottom. When we do rate of change, it's the difference in the y's on top and the difference in the x's on the bottom. So it's a little bit different from just kind of what your thinking has always been. You know, when we write an ordered pair, we always put x first. But when we do rate of change, we want the y's on top, so you do the y's first. So his mix-up is the numerator and the denominator. He subtracted correctly. We should have done, if we label this point, it looks like they did this one x1, y1, and this point is x2, y2. So on top he should have had 0 minus 2, and on the bottom he should have had 4 minus 0. Question 3 just asks for the rate of change, so when we do rate of change again, we can use that formula. I also teach students you can count the rise over the run. We start to relate rate of change to a word called slope. So what I'm going to do is just kind of pick some points here that the line goes through the graph at a point that I know. So all of those are points that we know. Now this line does have negative slope, so I know that the last two cannot be correct. And you can really pick any ordered pairs you want to try it or to calculate it. So if we pick 0, 1, and then I'll just pick this one right here, which is 1, negative 1. So we want to do y2 minus y1 over x2 minus x1, and I'm going to go ahead and label my points also. I'm going to label this one x1, y1, and this one x2, y2, and it doesn't matter which one you name 1 and 2. If you had them switched, we would actually should still get the exact same answer. Okay, so y2 is negative 1, so I'm going to do negative 1 minus y1, negative 1 minus 1, and on the bottom, x2 is 1 minus 0. So negative 1 minus 1 is negative 2, and 1 minus 0 is 1. Negative 2 over 1 is negative 2. You actually have the reciprocal of that, so I'm wondering if maybe you flipped your x's and your y's, but remember the y's always go on top, the y part of the ordered pair, so it's this answer here. You can also count rate of change, and if there's some more questions that come up, I'm going to show you a little bit of a shortcut. Look at the graph. Leslie analyzed the graph to determine if the function it represents is linear or nonlinear. So she's looking at several different points. Let me move this out of the way. She found 3 points on the graph. She determined the rate of change between the first two to be 1 and the rate of change between the next set to be 4. Finally, she concluded since the rate of change is not constant, must be linear. That's the exact opposite of what's the truth. If the rate of change is not constant, then it's not linear. The function must be nonlinear if it's not constant. Right? If we draw a line, no matter how I draw that line, the rate of change, how far it goes up and over, will always stay the same, kind of like a staircase, right? It's going to go up and then over and then up and then over, and that would always stay the same. But we have clearly a nonlinear graph. You can tell by looking at it, it's not a straight line. Linear just means it's a straight line. This graph is not straight. it looks like her calculations are correct, but her conclusion is wrong. Again, if the rate of change is not constant, then the function cannot be linear. It has to be nonlinear. Juno is taking a taxi. The table represents a linear function, shows the amount she owed after various numbers of miles traveled. The rate of change is 2.25. Oh, is the rate of change 2.25? So all you have to do here is take all of your y values and divide them by the x values. So you're going to take the money and you're going to divide it by the miles in every instance. And it all has to be 2.25. So 2.5 divided by 1 is 2. What? That's 2.5. Is this a typo? Oh, the difference. Okay. So what we're going to do here is I'm going to actually give you a shortcut. So if I look at and it's because the miles go by 1 every time, right? You can see that you're just going by 1 more mile every single time. So then how much is the y increasing by each time? And so if you just look at the 2.5 plus 2.25 is 4.75. 4.75 plus 2.25 is 7, and add another 2 1/4 and another 2 1/4, and you get all the way down the graph. So we actually don't need to do this. That actually only works if it's a proportional relationship anyway. So as the miles increase by 1, the amount she owes increases by $2.25. So that is correct. Yes, because the amount owed changes by 2.25. This is the money. So this is the amount owed. She doesn't owe $1. The miles are changing by 1, so you just maybe have your labels kind of flipped in this table. Okay, I'm going to have to scroll here. What is the rate of change? Yuck, these are fun numbers, aren't they? So we're increasing by 1 every time. If they're asking you what the rate of change is, then it is constant or linear. So it doesn't matter between which 2 points you check. I want ones that already have a common denominator. I'm going to try to take a shortcut here. So I'm going to try to use this one and this one because I'm going to have to do some subtracting. So this is going to be my y2, this is going to be my x2, this is going to be my y1, this is going to be my x1. So I'm going to do 35/48. This is going to be really ugly. Minus 17/35. That's y2 minus y1 over 5 minus 3. So I don't need a common, oh, I don't know why I wrote 35ths. That's supposed to be 48ths. There we go. 35/48 minus 17/48. So I'm going to grab my calculator to help me a little bit here. 35 minus 17 is 18, so I get 18 over 48 all over 2. Remember when you're dividing fractions, we do keep, change, and then we flip the denominator or take the reciprocal. And I can cross cancel here. Let's see, 2 goes into 18 9 times. That goes in once. So I get 9 over 48, and both of these numbers are divisible by 3. 48 divided by 3 is 16, so 3/16. Yep, that's the right answer, 3/16. Again, if they're giving you a table and asking you what's the rate of change, the assumption there is that it is constant. So you really can check any 2 ordered pairs. I did not want to have to be subtracting like some of these that don't have common denominators. That's why I picked these two, because the denominators are already the same, so it made the subtracting up top really easy. But those are super ugly numbers. Sometimes I think this program throws stuff in like this to make sure, are you really understanding the math that you're supposed to be doing? Because then can you do it with these really ugly fractions? Is the function represented by the table nonlinear? So again, this is increasing by 1 every time. So we need the table to do the same thing all the way down. So that's -2, and that's -2, and that's -2. So yes, it is linear. So the question is it nonlinear? So no, it's not nonlinear because it has a constant rate of change. So constant rate of change means it's linear. And when you graph that, wherever it is, it'll look like a straight line, right? There's your graph. So constant rate of change is a linear function. You know, it can go in the negative direction also. It can be horizontal. So those functions are all linear. And this one is as well. So we would say no, because it's not nonlinear. It's a lot of negatives. And again, it's because the rate of change is constant. Okay, I hope that helps. This is a pretty big topic in 8th grade. This rate of change, it's going to move into a term called slope, which is basically like the steepness of the line. And the rate of change problems are typically more real world type examples. You saw, you know, the mileage and the money in an earlier example. We get to actual slope and we just are looking at graphs all the time, but you've got a couple more attempts on your quiz. If you need some extra help still, please reach back out and let me know. Talk to you later.